Hello everyone. Now here we'll solve the problem on truss, two-dimensional truss using finite element based tool, that is using Hypermesh as a preprocessor and Optistruct as a solver. So here there are two truss members, and both the truss members are of the same materials, and the area of cross section is also same. The load applied is at this node point, and which is 20 kilonewton, and then we have to find out what is the displacement at this node point 1, and what are the element stresses. So we'll go to the Hypermesh. First we'll define the material properties, and so this is create material. So material is steel. This is a isotropic material, and material model is a mat 1, which is in Optistruct. So we'll take the default properties here. If we check whether the properties are same, so it is actually 200,000 MPa. So here we have to take, instead of these 2.1, so it is a 2 it is to 5. Density will remain same. So material is defined. Now we have to define property. So which is here we model this as a beam element. So in Optistruct. So property create. So we'll say this as a truss with beam property. So this is a 1D. Then we'll select the P beam property. Material is a steel, and here section is not defined, so we have to define the section first before defining the property. Okay, so we'll go for the geometry 1D, and section means this area we have to define it here. Okay, cross sectional area, and it should be equal to the 300 mm square. So we'll define this. So for that we have to go to the hyper beam, and here we'll take the maybe solid rectangle as a standard section, and we'll create it. So but we want area as a 300. So what we can take here, 10 into 30, if we take, so it is a 300. Okay, or other combination we can take, which will be a 30. So another combination could be a 20 into 15. So that also gives the areas. So 15 into 20 combinations can be okay. So we'll keep this 15 into 20. Now, so we have created now we can create the property. So go to the property, truss beam, and here beam section we can take this as so create. So we have created, so this material and properties, they are appeared here. Now we can so we will create the node points now here, node 1, node 2, node 3, like this. So the first node, coordinates of this node point can be so 300 y, so y is a 300 and x is a 500. So we'll create a nodes. Okay, so y, x is a 500, and y 500, sorry, 500, y is a 300. So create node here. So this node will be x is y is a 300 and x is 0. X is 0. So we can create this node, and this node will be x is 900 and y is 0. Y is 0 and x is a 900. So we can get this. So now here there are the two members, and it can be a single component because area of cross section and the material is same. So we can have same component. So we'll create now beam. You can go to bars here, property you can select as a truss beam property, element type will can be a C beam, and you can select this orientation section perpendicular to Y. So you can select from this to this and from this to this. So component is created here. So we can change this color maybe to red. Okay. So if you want to see this in a detailed one-dimensional view, so you can see this. This is the cross section. This is the truss being created here. Okay. So now, so for this component, we have to just update the component. This component, so no card image, but property here it will be a truss beam property, material and other things will get assigned. Mixed direct and indirect assignments. Okay. So, so here also from you can select here. I will give the name as you can rename this as a truss. Okay, so for this truss, let's check whether the property is a truss beam and material is a steel. So yeah. Now we have to create the load collectors. So we'll create load collector, that is a force, and we have to apply the force, and that force is 20 kilonewton at node 1. So let's apply this. So go to analysis. So force at this node, we have to apply the force, and force is 20 kilonewton. So it will be a minus because it is acting downward. 1, 2, 3, 20 kilonewton and along y direction. So we can create this force. Okay, so the force here you can see. You can change the color if required so that we can see. So this is 420 kilonewton is applied. And other boundary conditions we have to create, that is load collector, that is a single point constraint. So create, and when we are in the single point constraint, so we have to view the constraint, and this node will select and will fix all degrees of freedom. So the constraints are applied. Okay, so you can see here all degrees of freedom are constrained. Now we have to define the types of analysis, that is in load step, and here you can come down here, define that it is as a linear static, and this will be a single point constraint, and load is a force. Then now we can save it as a new folder. We'll create as a truss problem. So we'll rename it something 2D truss So it has been saved now. So again check that for this component whether we have assigned the proper property and material. Okay, so we'll go to the Optistruct, select the run option as analysis and run it. Analysis completed. So we'll go to the result and so go to the contour and just see. So this is orientation, and now here we got the displacement as maximum displacement as 0.77, and we'll check the element stress, and this is minus 87. Okay, so